Hi, so this is a special learning target for today. I was looking at the information currently out about the coronavirus and its spread through the United States, and thought I'd make a little exponential model learning target for both Algebra 1 and Pre-Calculus. Just because this is why I'm talking to you over camera instead of having you in here. So basically, our goals today are to interpret the exponential model of the coronavirus and the U.S. over the last 14 days. I took the data from the last 14 days, and we'll see. Algebra 1, we're going to evaluate the exponential model to predict how many cases in the U.S., how many cases the U.S. will have by a given day. And then pre-calc, we're going to use this model to extrapolate when there will be a given number of cases. So essentially, Algebra 1, we're going to evaluate. Pre-calc, we're going to solve. Because that's what we did earlier in the year with both of these exponential model learning targets, but without this context. So what I did is I went to this website, worldometers.info/coronavirus/country/US. There's a graph of the data on there. I'm going to grab it and just drag it over so you can see it. So basically, oh, come on. There's this cool jacket, but as you go across, what I did is I said March 10th, there were 994 cases, and then as you continue up, you can see the date and the number of cases. So what I did is I took that information and I put it into an online exponential regression calculator. So just plopped all those data values into a table, told the calculator to evaluate, and it came up with this information. So this graph, right, the means of x and y, you can disregard that. That's not really important. It's just telling you what this data is. Or sorry, the mean, the average, arithmetic average of all those numbers for x and y. But here, correlation coefficient, the a value and the b value are what we care about. So what does this information mean? So the correlation coefficient, this is how good of a model is it? And basically, and sorry, this is the correlation coefficient. This is the R value. If this R value is close to 1, that means it's a pretty good exponential fit, or sorry, pretty good fit for an exponential function. So we look at this correlation coefficient, we get this number, 0.998281994. That is really, 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 really close to 1, which means this data is following a very, very, very exponential pattern. Okay, the A value. The A value is this model's estimate, or sorry, what this model picks as its starting value. So as March 10th, we would say there were 908 cases, 908.63. Really, there were 949. The model is not perfect. It is a statistical regression of these values. So it's basically the best curve that you can fit in between all those points. It doesn't have to go through any of the points necessarily. It's just closest. It's the curve that goes closest to all of them together, basically. So here, this is the model's starting value. That's the A value. And the B value, this is the model's growth factor. So, it's an apostrophe. And this is 1.343851987. So, by growth factor, what I mean is this is the number that we multiply, or sorry, that the population multiplies by every day. So if there are 100 cases, the next day there would be 100 times that, or about 134.4 cases. And the next day you would multiply that by 1.34, and so on and so on. And that's what gives you this shape of the curve that gets really, really steep at the end, is because we're multiplying over and over and over again. So let's dive into this. Now that we have the A value and the B value, so our starting value for our model and our growth factor for our model, and we're convinced that an exponential model is a good choice because that r value is really, really close to 1. We're going to write the equation, we're going to define the variables, talk a little bit more about it, and then we're going to actually do some problems with this. So the equation here is going to be y equals 908.6304, that's the a value, times 1.343852, I rounded a little bit, and then to the x, where y is the number of cases since March 10, and this is in the USA. And sorry, this is confirmed. This is the number of confirmed cases. We don't know how many cases are actually out there because we haven't tested everybody. So this is all, I mean, this data is all based on that website from confirmed cases that have been released. X, this is the number of days since March 10th. So given the number of days since March 10th, and that's just an arbitrary number that I picked off that graph, started at 10th and went to today, which is the 23rd. So given the number of days here, the output is the number of cases. So the b value represents the growth factor, which is 1.343852. The growth rate, so remember when we did this before, y equals a times b to the x, we can write this, if it's growth, we can write it as y equals a times 1 plus r over 100 to the x. And we can say, well, what's the growth rate? The growth factor is the b value, is the 1.34. So the growth rate is this r. So here, if I take away the 1, and I move the decimal over a couple spots, in other words, multiply it by 100, I get the growth rate, which is r, is about 34.3852%. Excuse the bell. There are no students here, but the bells are still going off, so sorry about that. So I am social distancing. I'm the only one in the room. So 34.3852%. So that's huge. If you had this in your stock portfolio, you would be loving life. You'd have a ton of money in like 20 years. Like, crazy. So that's a huge growth rate. The a value represents, we already talked about that, this 908.63, this is, so 908.6304. This a value is the starting number of cases on March 10th. Nope, that's March 10th for the model. It's not the actual number of cases, it's the model's number of cases for March 10th. All right, so we're going to go ahead and we're going to use this model to answer some questions. So, applying the model to make predictions from that equation, Algebra 1 learning. So assuming that this current trend continues, and that's an important caveat there, we're assuming that this trend continues, how many cases can we expect to see by March 31st? So what we're doing here is we're doing what's called extrapolating. We have this set of data between March 10th and March 23rd, and then we're saying we're going to pick a value outside that data set, the 31st. It's quite outside. And we're just saying, hey, assuming that that continues. This value, this answer we get, does not mean that's going to be the actual answer. That just means if this same trend continues. So that's our Algebra 1 question. Our pre-calculus question is, assuming the current trend continues, again, when would there be 1 million cases confirmed in the United States? All right, so starting with the Algebra 1 learning target. So March 31st. So remember, X is the number of days since March 10th. So if it's March 31st, that means X equals 21, because 21 and 10 make 31. So what we do is we go to our equation, our model, 908.6304, times 1.343852, and then instead of an x, we put in a 21. And then we take a calculator, because we're not going to do that in our head. No way. Go to our calculator, we just plop this in the calculator. 0.6304 times 1.343852 to the 21st, and we get about 450,575, and then it's 0.47 confirmed cases. So we will expect about 450,575 confirmed cases of COVID-19 by March 31st. This is if this trend continues. That's a huge number. Right, that's about 10 times bigger than what we have today. And that is in 8 days. So in 8 days, we'd expect the number of cases to increase by times 10. 10x, that's a ton. Okay, so still, and sorry, for this learning target, all we did is we said, hey, March 31st, how many days since March 10th? That's our x value, replace x in the equation, use our calculator, find the number, round it, and then write a sentence answer, right? So instead of just giving a number, we explain what that number means. All right, so now the pre-calculus learning target. When will there be 1 million cases in the United States? So this is a y value. The 1 million is a y value. So it's saying how many cases. Remember, y was the number of cases since March 10th. So, I'm sorry, it's y is